Okay, so very good evening everyone and welcome to the chemistry class. So I hope you people are keep on revising the topics, you people are looking in the NCERT and the reactions which we have covered till far, right? Okay, so we will do first the quick revision. As you are able to see that now we are more proceeding towards the chapter number 2, that is the alcohol, phenols and ether, right? So let us start. I'm just giving you the few questions and then you people will tell me. Okay, one thing more, because this particular topic is being running parallelly in many of the classes. What was the last topic of the class? Anyone just write down which reaction we were doing in the last of the class. Then we will start with the revision also, okay? I just want to know that what is the last topic of our class. I have Satna Center with me, and Shillong is there, and St. Paul is there, and all the other different centers. Please write down something so that I get to know that you people are there. Okay, so I am also writing it here. Okay, addition reactions we were doing. Thank you so much, Shirley. So I am just writing the topics which we have covered till far, okay? So all of you are aware with the electrophilic aromatic substitution. Why I am writing it? Because this is a kind of revision we are doing, okay? And what we have done, we have studied so many things here. We have studied about the halogenation, Cl2 in the presence of AlCl3. We have talked about here the nitration, the HNO3 plus the H2SO4. When we have, okay, I have the Aiswal Center, Senapati Center, St. Paul, and one more center is there. Okay, nice. So what I'm saying that in the electrophilic aromatic substitution, we have studied the 5 types of reaction over there. Look at the screen, everyone. One is the chlorination, then is the nitration, then is the sulfonation with the H2SO4. After that, we were having one more, the Friedel-Crafts reactions, okay? So I'm just pointing it down. It was something like when you have Rx in the presence of AlCl3, and there was one more which is known as RC double bond OX in the presence of AlCl3. Here I haven't written the names, but I have written the reagent. First is halogenation, then nitration, then sulfonation, Friedel-Crafts alkylation, and then Friedel-Crafts acylation, right? Okay. Okay, Sercon is also there. Welcome, Sercon Center. We are just revising the few topics that what we have studied till far. After that, can you people tell me what we have done after that? Any of you tell me what we have studied after that? What we have studied after that? Anyone? I think before Grignard we have studied one more thing. If I remember that we were studying the free radical mechanism. Free radical mechanism. This is something, when we have simple alkane, let's say CH3, CH2 and CH3. And when we talk about Cl2 in the presence of H mu, what we used to do? We used to write, you people used to say that, ma'am, this is the product. This is an alkane, or I should say the halogenation of alkane, right? Remember? After that, what we have done? Yes, I do remember. Nucleophilic substitution. I guess before the free radical, we have done one more topic. That was the SN1 and the SN2. Remember, everybody? Everybody is recalling it. You can turn your pages back, just have a look, because revision is important, right? You should know that which type of reagent is there, and this reagent works like this, and this is the work. All of you remember what is the difference between SN1 and SN2? SN1 was the two-step reaction in which we got the carbocation as an intermediate. Then in the SN2, it's a single-step reaction, right? And in the single-step reaction, we get directly the product, the substitution, right? So SN1, SN2 is done, free radical mechanism is done. Any doubt in these 3 reactions which I have written on the screen? Quickly write down, I'm waiting. Shillong, what's your camera code? It's 8081. Okay. Anyone having any doubt till far? Clear to everyone? No doubt, I guess. Okay. Then after that, what we have done? Tell me, after the free radical mechanism, what we have done? You people will going to tell me. Yes, Satna Center, right. After that, we have talked about the Grignard. You people remember that? GR is the Grignard. In the Grignard, first we have talked about what? Yes, acid-base reaction. You people know that. Let's say you have CH3MgBr kind of thing, and when it reacts with the water, okay, and then we can have something like CH4, okay, because most probably in the upcoming weeks there will be your test, so it will be from haloalkanes, halorines, and I know that you yesterday was also your test, right, for the physics, I guess. How was it? How was your exam yesterday? You people have given the exam, right? Tell me, I'm waiting. It's okay. Nice. Waiting for the results. Okay. Okay, have a look on the screen. So after that, we have done the nucleophilic addition also. You know that nucleophilic addition is, actually done in the case of aldehydes and the ketones. When you have the aldehyde and when you have like CH3MgBr in the presence of H3O+, it forms alcohol. And you people remember that we have done the different degrees for the alcohol. Okay. Good evening, Senapati Center. Senapati Center, we are just doing the revision right now. Okay. After that, what we have done, you people will tell me. I'm waiting. We have done Grignard, we have done acid-base reaction in the Grignard, nucleophilic addition reaction in the Grignard. Any other reaction we have done? Tell me. I want you people to tell me that what we have done after that. Conversions. I guess after that we have talked about some of the benzene diazonium salt, okay? This is the benzene diazonium salt. You people remember that? We have done the preparation also, in which I have, asked you to tell me what was the convergence. Okay, and if I'm sure, if I'm not wrong, I have given you an assignment also, okay, regarding those conversions. So, in these conversions, like the preparation is very, very important for the diazonium. We have done two things. There we have written the preparation, and then we have written the reactions. You people remember we have done a lot of reactions for the diazonium, like these types. Anyone having any idea? What will be the product? Tell me the answer. I'm waiting. And Shillong, just check your camera port because I'm not able to see any student there on the screen. What's your camera port, Shillong? Just write it down again. Shillong Center. And what will be the answer of this question? Yes, Satna Center, the answer is correct. Any other center? St. Paul, what is the answer? St. Paul, Senapati Center, Aizwal, and Sircon. The answer will be chlorobenzene, right? What happened? I have to increase my volume. From my side, I guess the volume is perfect. Rest the people will check. There might be some problem at your center, Senapati center. At my side, everything is okay. The volume is already maximum, okay? So this is the benzene trizonium, and when it reacts with CuHCl, you will get a chlorobenzene. And do you people remember this one also? Try this reaction also. You can just turn your pages back, okay, and then tell me. What will be the answer of this question? Tell me. Very good, Satna center. Any other center? Yes. So the answer will be phenol, because today we will be doing the preparation of phenol, and we will be repeating this particular, we will be repeating this particular reaction. So always remember that we have a disonium. When it reacts with the water, then we will get the phenol. It's one of the method of preparation of the phenol, okay? So this is the one thing. After that, what we have done? After that, we were doing the elimination. So in the elimination, what things we have done? Like you know that when we are talking about CH3CH, and when we have OH here and let's say CH3, and if I write here concentrated H2SO4 with the heat, what you people will do? What you people will do? You people will make it simply like CH2, right? So this is a very important thing. Is it clear? And we have done one more type of elimination. Okay, you people will going to tell me the answer this time. Alcoholic KOH. You people remember that we used to say that elimination will take place when there will be heat. So what will be the answer now? Write down the product, everyone. What is the answer? What will remove? The chlorine will get removed, and what will you get? Tell me the name of the product. You will get the elimination here, right? So it will be like CH3, and you can remove the hydrogen from any of the carbon. Every position of the carbon is equivalent. So it will be more like double bond CH2. This is the answer. 2-methyl propene. Yes. Clear to everyone? I hope this is clear to everyone. And you can do these types of questions. We have done them. Okay? And after that, what we were doing, we were talking about, see, have a look. These are the topics which we have covered till far. ESR reaction, free radical mechanism, SN1, SN2, then Grignard, then is the disonium. After that, elimination, and after that was the addition. We have done addition reaction. Try these one. I'm giving you the questions directly, okay? You people will try and then you will tell me the answer. CCl4 is the solvent. Write down the product, tell me the answer. If you remember, this is the addition of X2 in the presence of CCl4 as the solvent. So what will be the answer this time? How many chlorine will get added? This is the main question. As well, you have written CH only. Okay, do you people get this as the answer? Because you know that we will be adding chlorine at both the sides. Okay, it's an addition reaction. You are adding something. So the answer will be 2,3 dichloropropane. As well, this is the answer you are getting. St. Paul, where are you people? Nobody is replying today. Why? Yes, as well. Good. St. Paul Center. Shillong, any doubt? Shillong, first of all, I think your camera port is something different because I am able to see the vacant class here. So Shillong, if you have any doubt, just let me know, okay? Try this question also, everyone. Write down the answer. What will be the answer of this question? Where will you add the bromine? This is now the addition of HBr. So at one side the hydrogen will be added, at one side the bromine will be added. Yes, very good, St. Paul. So can I say that Aswal Center, it will be a Markovnikov addition. You people remember we have done Markovnikov addition also. So if we are doing the Markovnikov addition, the product will be like this. You people remember the Markovnikov rule, okay? So higher will get higher. So higher means what? Higher hydrogen. The carbon, this is already having the higher hydrogen, right? The 2 number of hydrogen are there. So we have added 1 more hydrogen here, okay? So higher will get the higher, okay? I guess these types of questions we have covered in the last class, okay? Okay, what about the addition of water? This is the addition of X2. Can we use anti-Markovnikov? Anti-Markovnikov will be used in this question as well, Center. Whenever peroxide is written as well, then you can use anti-Markovnikov, okay? Like if I am writing, I am giving you the same reagent, but this time I am writing HBr with peroxide. So they will mention peroxide or either they will write the formula which is H2O2. So either they will write the peroxide or either they will write H2O2. Now you have to perform the anti-Markovnikov, right? So if I perform anti-Markovnikov, what will be the product this time? It will be like CH3, then CH3, then H, and it would be CH2Br. Your earlier answer was related to the anti-Markovnikov addition, okay? Clear to you as well, Center? Senapati Center, Shillong, any doubt you have? Good. Okay, so if I talk about one more thing here, I'm not sure that we have done this thing also or not, but if I have, let's say, the addition of water, now you people will tell me the answer. We are adding the water here now. This is something we can use anti only in the presence of peroxide, definitely as well. One more thing is what? Peroxide with the HBr only gives anti-Markovnikov. What if I write HCl with the peroxide, na? HCl with the peroxide will give again Markovnikov addition. Only in the case of HX, HBr with the peroxide, this particular reagent will give anti-Markovnikov addition. That's it. This is the important thing, right? Now, when we talk about the addition of water, let's take some examples. You people will try and then tell me the answer. If I have water, what will happen? Simply they will either write the water or they will write the H plus like this will be written on the question. What will be the answer? Anyone? What will be the answer? Very good. So OH will be there. And where will you put the OH? You people remember this thing now? That H plus will attack, and again, either you can just remember that you have to do the Markovnikov addition again. So what will be the answer if we are doing the Markovnikov addition again? This will be like this thing. Okay, so this is the answer. Try one more question. If let's say I am writing H3O plus now, this is the same thing. Either you can write H2O in the presence of H plus or either you can write H3O plus. Write down the answer now. What will be the answer this time? Butane 2-ol. Now, if you are able to see that if you are going to do the Markovnikov addition, at both sides the number of hydrogen is same. So, you know that you can add the OH at any of the side. This time no problem is there. I am simply saying that we can add the OH at any of the side. So, what answer I will be getting? Either you can, attach it here or on the another carbon. So the answer will remain same and you can say yes, this is the butane. It's not but2-ol, Satna Center. You have to write butane, right? So butane 2-ol, this is the answer. Try this one. And I am writing 1 and 2. You people will tell me that you will add the OH at number 1 carbon or number 2 carbon. This thing I want to know. You people will add the OH at number 1 carbon or number 2 carbon. So Aizwal has written, I guess, number 1. This is the center, which is Zircon. Okay, Zircon has written number 1. St. Paul, why number 2? Senapati is also saying number 1. Aizwal is also saying number 1. Satna Center is saying number 1. St. Paul, it obviously the number 1, right? Because you have to do the Markovnikov addition, okay? So you are able to see that there is no carbon here. But at this position, there is 1 carbon left. So just do the Markovnikov, apply the Markovnikov rule. What you will get? Here you will get H, and H obviously here is the OH. So you are giving the higher, will get the higher. This was the rule. So higher carbon having the, or we can say the carbon having the higher number of hydrogen will get more hydrogen. This is the answer. Any doubt? St. Paul, any doubt you have? Itanagar Center, any doubt? Okay, Itanagar was saying number 1. Good. So it's easy now. I hope everybody is getting it easy. Okay, no problem, St. Paul. Only thing is that you got the concept, right? So we can now write the products of the addition reaction. And one more thing. See, this is the one way to add the water in the double bonded system with the Markovnikov rule. Now I am talking about the anti-Markovnikov rule in the water. Anybody knows it? Anybody has any idea that, let's say, if I want to, make the alcohol, again we will be making the alcohol, but that too by the anti-Markovnikov addition. What will be the reagent? Anyone? Any idea with the reagent? Tell me. No idea? Okay, look at the screen. I am writing it. We are again in the water. See, this was by the Markovnikov rule. Okay, so this was by the Markovnikov rule. See now, when you want to add the water, that too by the anti-Markovnikov rule, what will you do? I am writing the reagent. Again, you have some idea that when we have peroxide, then there is the addition via the anti-Markovnikov rule. Now remember that we have B2H6. Okay, so B2H6, like this was, I guess, the last topic when we were doing in the class. Diborane is there. This will be the reagent. Don't get confused. You have to remember that this reagent also converts the, also do the addition. And we will be getting the alcohol. But the important thing is that we will be getting the alcohol via the anti-Markovnikov addition. So, if I do the anti-Markovnikov addition, it will be like this. And B2H6 is what? It's the diborane. Although, no need to go for the mechanism. You have to remember the reagent and then you can just go for it. Yes, I can explain it in detail. First of all, just write it down. Actually, there is a perfect mechanism also. Perfect mechanism for this diborane system. But I am not telling you because they will not going to ask you. It is not even mentioned in the NCERT Sercon Center. Okay. That is why the important thing is that you should know. There are 2 ways of doing the addition in the alkene and you will be getting what? The alcohol. But the first way is the Markovnikov addition and the second way is anti-Markovnikov addition. Now both of them has the separate reagents. Like this one has the separate reagent, okay? Like I can give you the detailed idea for the H2O, that is simple. But this diborane, this process is quite lengthy and nobody is going to ask you, so we will not go into the mechanism for the second one, okay? This is clear? What is H2O2? What is the need of H2O2? Always remember that. This is the peroxide. Peroxide always favors the anti-Markovnikov rule, okay? If I give you the little bit idea of that, it's something like, or no need to do that because it will create a lot of mess over here because certain things you know right now, certain things you don't know, okay? Like for the diborane also. So I'm not explaining that. But the important thing is I want you to do this type of question. Try this one. Try this type of question. Actually, what happened, Naharlagan Center, in the presence of H2O2, B2H6 works in the manner such that we will be getting the anti-Markovnikov rule, okay? So it's a detailed mechanism. We are not doing that. You have to write the products for both of them. Just write down the products. You will get some idea. They both are the preparation of alcohol. Oh, what I got, this is what, 1,2 might be, methyl propane 2-ol, okay. Propane 2-ol from the zircon. Okay, Satna Center has replied, Senapati Center has replied. Naharlagan, what is your answer? You got the answer? Itanagar Center, St. Paul, Aiswal Center. See, in the first one, you have to perform the Markovnikov addition. It's very easy. Everyone listen to me also. Let's say if you are treating this particular compound with the H+, what will happen? You know that how you will be breaking this particular bond I'm saying. You will be breaking it something like this one, right? CH3+, and here you will be, this particular thing will attack over here. So what I am doing, I am just attacking it like this. I am writing it like this. That I will be getting, if I break this bond, I will getting this side plus and this side negative. And then this hydrogen will attach over here like the H+, okay? This is what I am saying. The reason is because at that center carbon, the positive charge is more stable, okay? So this thing is quite clear. We have done it in the earlier classes also. So I am directly writing the product, or no need to write the mechanism in the exam. You have to directly write the product, okay? Here it will be the OH. Here it will be the CH3. What happened? St. Paul, 100%. Now in this question, what will happen? Yes, Aiswal, your answer is correct for the first one. Good. And many of you have given the correct answer. Very nice. Now what will you do here? You will write hydrogen here because you are doing the anti-Markovnikov addition. And then CH2 and then OH. So this is the answer, okay? Clear to everyone? I guess this is now clear to everyone there. Try some more questions related to it. Try this one also. Yes, Itanagar, this is correct. Itanagar, you got the same products which I have drawn on the screen. I hope you got the same product. Now you have to perform again the anti-Markovnikov rule in peroxide. Miss, in the first product, can OH below the plane? We haven't talked about the plane yet, okay? And we cannot say this is below the plane or out of the plane. Zircon, the reason is this particular carbon has these three groups same. So it doesn't matter, okay? It doesn't matter. Always remember, we talk about out of the plane or in plane things in this type of carbon. when we have one carbon and this type of system is written to you here, okay? And all of the 4 groups of the carbon are different. Only then, when all of the 4 groups of the carbon are different, then you can justify that this particular group is out of the plane, this is in the plane, this is towards, and something like this, okay? So this will happen only in the case of what? When you have this type of system, right? And in this particular case, we cannot say that, we cannot say that this is out of plane, this is in plane. Because I have 3 methyls at the same, okay, the same groups are attached. What is the answer here? You people just tell me one thing. This is the number 1, this is number 2. Where will you put OH? Shillong, I guess I'm able to see you all. Can you people raise your hands? The students from the Shillong Center. Can you people raise your hands? And how many students are present? Just write down the attendance also. Shillong Center. How many students are present? Just write down the attendance also. Because there are some students in front of me. I'm not sure that you people are there or not. Okay. So where we will be going to add the OH? Zircon center. Why you are writing that number 1? We have to do anti-Markovnikov zircon. So anti-Markovnikov is opposite, right? Yes, Naharlagan, you are correct. So the answer will be like this. This is the right answer, right? Just the opposite of the, the question which we have done in the case of H2O. The reverse thing will happen over here. So I hope now all of the additions are clear. How many types of additions we have done? The number 1 is addition of Cl2. Number 2 is the addition of HX. Then the addition of water. And in the addition of water, we have done 2 cases. One is the Markovnikov, other is the anti-Markovnikov. And you people know that the similar kind of things will take place when we will be talking about the addition in alkyne. Okay. Let's first write those reactions also, and then we will talk about the phenol. Write the next heading, the addition in alkynes. And you people will try this, okay? Five students are present, okay. But your camera, I guess, the port is not working, because I am not able to see you all. Everyone just try this thing. If we have Cl2 again and CCl4. And go step by step. First of all, break 1 pi bond and add the chlorine to both the sides. Then make alkene and then perform next step also. Again with the Cl2, CCl4. Try this question, everyone. Tell me what is the answer you are getting. Just try by your own, then I will tell you how to do it. What will be the answer? We have the triple bond, okay? So what will you do? See, listen to me, everyone. What we will be going to do, like if I go step by step, very good, Satna Center, you have done the complete reaction there, right? Good. Yes, Itanagar, you have written, I guess, the step 1. Good. Now everyone just look at the screen. If I go step by step, what will happen? I will be breaking the first pi bond, right? So I will be writing CH3, then C, double bond C, CH3. Here one Cl, here one Cl. Same thing which we were doing in the alkene. The same thing. Yes, Aswal, which you have drawn is correct. Now tell me, Aswal Center, if I perform the reaction again, CCl4, what will happen this time? Now again, break one more pi bond and now again add 1,1Cl. So, this time, like in alkyne, if we do the direct reaction, we will be getting the 4 halogens, okay? So, what will be the answer now? See, I am drawing it. I will be getting CH3, Cl, Cl, right? So, it's something like 2, 2, 3, 3, tetra, chloro, butane. Or many times this is also written that in the books they used to write this is a tetrahaloalkane. So this is correct. Anybody having any doubt in this reaction? Yes, Itanagar, this is correct. Good. Aswal, any doubt? St. Paul, Shillong, any doubt? Can you explain what happened? Zircon Center, in which point you have the doubt? Zircon, it's very easy. Look at the screen. First, we have broken the first bond. Look at the screen. I am explaining. This is the first pi bond. Break it. Okay. And I get like this is the Cl plus, this is the Cl minus. They will go and attack. At both sides, I got the chlorine. Okay. Then I have broken this pi bond again. And again, I attach the 2 chlorines here. This is what we have done. It's very similar thing. Look at the screen, Zircon. Zircon, we were doing this type of question, na? For the double bonded system. What you used to make there? You remember that you were making this type of product? You remember that? I'm saying that this is a very similar kind of reaction. This was in the alkenes. And this is what we are doing in alkyne. Take your time, have a look and tell me. Clear now? Everyone, it's clear. It's very simple thing. The only thing is that in the alkyne, you will be adding it 2 times. Okay? Now, if I'm writing this question, you people will tell me the answer for this question. And directly, no need to write in this step. Directly write down the answer. Excess is given. Just make the last product. You can try this question, Zircon Center. This time I have given you Br2 and then you will be making it. Wait, Satna Center, we are just going to write that question, yours question also. We will be adding HBr, HCl into the triple bonded system. Don't worry. What will be the answer of this one, everyone? Write down this one. You have a triple bond, you have the bromine, and you have to write the direct product. Like when we will be having the 4 bromines in the compound. This is Br, I guess. Aswal, you have written R. That might be Br. See, I am making the product and you people will check. CH3CBr, then one more Br. This is the hydrogen I am making, the bromine and the bromine. How many of you are getting the same product as I am getting? How many of you are getting the same product? Okay, Aswal got it. Okay, Zircon Center got it. Satna Center got it. Itanagar, Senapati Center, St. Paul, and Shillong. And all the other different centers. CC-Pur was also there. CC-Pur, Itanagar are different. Is it clear now, Itanagar? Just have a look, okay? It's again the same thing you are doing, like we have done in the earlier reaction. Okay. So who is left? Which center is left? Shillong, you left for the reply. Shillong, and CC-Pur was also there. CC-Pur center, you are there? You are getting the answers? You have any doubt? Okay, that is nice. So CC-Pur, I hope you are also getting the answers. That is good. Okay then, okay. So these were something like when you have an alkyne and you are doing the halogenation there. Now, like one, okay, Shillong, good. You also got the answer, very good. So I was just saying, like one of the student asked me the question that, ma'am, what if we are adding the HBr? See, we have done the addition of HBr, HCl in the double bond. Now I'm giving you one more question, okay? Try this question. Let's say if I have C triple bond CH and you have to add HCl here. What will you do? First of all, try to write it in the step, and then, because by writing in the step, you can ultimately get the answer. Do the Markovnikov addition. Satna Center. HCl is there, you can do the Markovnikov addition. And this time you people will tell me that whether you are getting the halogen at the same carbon or the different adjacent carbons. Try this in two steps. In the same way you will proceed the reaction. First break one bond, then add the H and the Cl. Take care that where you will be adding the Cl, okay? Yes, you have to apply the Markovnikov rule. Satna Center, just apply Markovnikov rule. Itanagar CH3CH, then Cl, okay, and then CH3. But this is the one-step process. You got the double bond Itanagar. Second carbon, we have 2 chlorine. Very good as well. This is the right answer. Satna Center, your answer is also correct. Very good. Look at the screen. Like if I go step by step, then what will happen? I have to do Markovnikov addition, I know that. So it will be like chlorine here. First I have the double bond and it's like CH2. I was saying that what if I again add the HCl here? Then what will happen? Again perform the Markovnikov rule. So what you will be getting? You will be getting CH3, then carbon again Cl, and this is now CH3. This is the answer, okay? So it is like 2,2 dichloro-propane. Have a look. If any doubt is there, tell me. It's 2,2 dichloropropane. And we have done it in the step by step. I have just written the step by step in order to make the things clear to you. If it is written in the triple bond, you directly make the product and reach up to the third step, okay? Like the final product you can write. No problem is there. No need to write the steps then. No problem, Itanagar. You got the same answer. That is what I want to know. If you got the same answer, then it's good. And I hope you got the concept as well. St. Paul, you are getting the answers? St. Paul is not replying so much today. Why? What happened, St. Paul? Everything okay? So this is the way you can do it, okay? Try one more. Okay, Nahalagan too got the answer. Very good, Nahalagan Center. Nahalagan, try one more question. And directly make the last product. Tell me the last answer, okay? No, you can write in the steps if you want, but I need to know the complete last answer. Write down the answer of this question. What is the answer? 2,2 dibromobutane. Dibromo or tetra or 4 bromines you will be getting. Satna Center. You have to tell me the last end product, right? So, and one more thing, this time you will do not get confused that you have to apply the Markovnikov rule. Because we don't have the hydrogen anywhere, so you can, first step you can just take place at any of the carbon. No problem is there. So I can either add the bromine to the one side carbon or I can add to the another carbon. There is no problem, okay? So I am going to write the end product. So if I am writing, this is what I am saying as well, that both of the things are same, okay? So either you can write the 2 bromines on this carbon and you can get this, and either you can have this answer also, no problem, like this. Both of them are actually identical. You can write the IUPAC name. Just write the IUPAC name, the names will be the similar one. It means both of the compounds are same, okay? That is why I am saying that if anybody has drawn the structure 1 or anybody has drawn the structure 2, the answer is same, okay? No problem. Clear? Serkon, yes, your answer is correct. Good. And I hope the Itanagar, you got the same answer. Itanagar Center. Senapati Center, Shillong again. Shillong, you are getting the answers right. I don't know which room today the Shillong is sitting. Your camera port and ours camera port, the number is not similar. So this is how you will be adding the HBr there, right? So whenever you have this type of question, okay, that is nice, Senapati Center. Whenever you see these types of questions, these are very easy to write. I hope nobody is finding it difficult. These are very easy questions, okay? So you can add the halogen or you can add the HBr or HCl, you will be getting the products. Now the important thing is, like in the alkyne, the important thing is about the addition of the water, okay? Let's talk about the addition of the water. In the same way we will processing like we have done in the alkenes, okay? That one step was of the Markovnikov rule, the another can be the anti-Markovnikov rule. Same way you can just go here, I am writing it. Addition of water. In alkynes we are talking about, okay? The first one is the reagent which we will be doing the Markovnikov rule. Everyone, I'm just writing the reagent here, okay? We usually do not only write here the water, but we used to write it like as the Hg2+. That is in the acidic medium. In many of the books, the name is written as oxymercuration also, okay? When this is written in the presence of water like this. Now what will you do? I am telling you, this is the reagent, but we are not bothering about the reagent. We know that we have to put the OH group. Everyone just try it, okay? Tell me the answer, what you will be getting. If you break one bond and if you do the Markovnikov addition, at which carbon you will be getting the OH? This is my number 1, this is my number 2. You people will tell me. At which carbon I will be getting the OH? What is Hg2+? It is nothing, it is mercury. What happens, Zircon? Zircon, Hg is mercury, right? It's the ion of the mercury. So ion of mercury is used as a catalyst, okay? 2, Senapati Center, we have to do Markovnikov addition here. Markovnikov says the higher will get the higher number of hydrogen. So don't you people think that I will be getting this type of the product? Very good. So everybody is saying this. So we will be getting this as the product. Now everyone, first of all, look at the screen, okay? No need to write. I'll give you the time to write. Just try to understand it. I am saying that this is the again a one step, okay? If I want to go ahead, I can write again Hg2+, then H2SO4 and the water here. Again perform the Markovnikov addition, I am saying that. Now you people tell me, this is the number 1, this is the number 2. What will you do? What will you do? In the second step, if I again do the Markovnikov addition, at which carbon I have to put the OH? 1 or 2? Very good, Satna Center. 1 or 2, very good, Aizwal. 1, everyone is saying 1, okay? Senapati Center again, we are doing the mistake, not at the 2. It goes to the number 1, okay? So, do you people think that I will be getting this type of product? CH3, this is the carbon, one OH, then another NOH, then it's like CH3. Now, what is very important thing is, it's very important to know that, it is when you have 2 OH at a single carbon, it's kind of unstable. They don't remain like this, that we have a carbon and 2 alcoholic groups are present on a single carbon. This doesn't usually happens. Then what happens whenever there is a condition that we are getting the 2 OH groups on a single carbon, they go away in the form of water. Very good, Chitna Center. So water will be removed. So look at the screen, everyone, those who don't know it. I am taking this OH and this hydrogen and I am removing the H2O. I am removing the H2O. So you people tell me now what will happen. If we are, breaking that, we are removing the OH also, we know that carbon is actually having the 4 bonds. But I am saying that you are breaking this bond. You people are breaking this bond. So what will happen now? Don't you think? See everyone, what is happening? This will be the OH negative, this will be the positive. We have removed the OH, we have broken that carbon-OH bond. At the same time, this H plus is also going. Yes, so what will happen? We will be getting a double bond between the carbon and the oxygen. Everybody is getting that. I am saying that we will be getting this double bond here. Very good, Aizwal Center. There will be a ketone group here, okay? So same thing you have to perform here. You can remove the water from here. I am doing that. Remove the water. What you will be getting? So what you will be getting? You will be getting this system like CH3, carbon, double bond O, CH3. So this is ketone. So I am just telling you that whenever we are doing the Markovnikov addition in the triple bond, we will be getting ketone as the end product, okay? This type of reaction will be used, this type of reaction is used in the preparation of ketone. But why Naharlagan? Because this happens here. At a one single carbon, 2 OH do not, you cannot keep the 2 H like this. Because what happens is the reaction is so fast that automatically the water goes out, okay? So they have the tendency to form the water first. So immediately, because you have the very, close vicinity of H plus and OH negative. So they together makes the water. Now everyone just write it down, tell me once you are done. And Naharlagan, I hope your doubt is clear now. Itanagar was writing COH. No, COH will not be there. Itanagar, clear now to everyone. Naharlagan Center and Itanagar Center, I guess this is clear now. Itanagar, any doubt? You can ask me. And this is not only when we are talking in alkyne, okay? This is a very general thing. Whenever in any kind of reaction you see that at one carbon you have 2 OH, just remove the water out, okay? In order to have the stability, it happens. Once you are done, just tell me, okay? So this is something like you are doing the Markovnikov addition in alkyne. Everybody done? Now I have told you about the Markovnikov addition. In the same way, you people can do the anti-Markovnikov addition. Okay, let's write. This was the Markovnikov rule. Only again, the reagent will again that peroxide. You know this thing. That when you see the peroxide, you will be getting the anti-Markovnikov rule. So if I write anti-Markovnikov, addition, or you can write the anti-Markovnikov rule. Try this thing, everyone. Now you people will try. Go on step by step and then tell me what you will be getting in the last. Okay? B2H6. Again, I can have OH negative with H2O2. Peroxide in the presence of B2H6 performs anti-Markovnikov. Try this one. Tell me what answer you are getting. So what is the answer? Sorry, we will get aldehyde. Ma'am, can we have two answers? How you are getting two answers as well? Just do the anti-Markovnikov, okay? See, Satna Center is saying that we will be getting aldehyde. Now, how many of you are with the Satna Center? Shelly is there. Shelly is saying that we will be having the aldehyde. Let's see how many of you have the aldehyde and how many of you don't have the aldehydes. Tell me. Same way, you have to proceed the same way. Very good, St. Paul. St. Paul, you are getting 2 OH. Remove the water. Those who are getting the 2 OH at the last carbon, remove the water. Serkan, perform one more time anti-Markovnikov rule. Yes. So St. Paul, this is correct what you are getting. I am saying remove the water now and make the double bond with the oxygen. What you got? Anybody? What is the answer? Okay, I am doing it now. See, I have to perform anti-Markovnikov rule. I know that I will be getting what? Hydrogen here and double bond CH and OH. Again, we have to do the anti-Markovnikov rule and directly writing it. Okay, this is the CH, CH2, this is the CH, OH here, and again one more OH. Now I am saying those who are getting this particular thing, that you are getting the 2 OH at a single carbon, remove the water. Okay, just remove the water. What you will be getting now? Just make the bond with the oxygen, that's it. So it's like CH3, CH2, C double bond O and H. What is the group here? This is aldehyde. Okay. So in the Markovnikov addition, yes, St. Paul, this is correct. I hope the other people are also getting the aldehyde. In the Markovnikov addition, we will be getting what? Ketone. And in the anti-Markovnikov addition of the alkyne, we will be getting aldehyde. So always remember this thing. It's a very important reaction, okay? Aizawl Center, you got the same answer. Itanagar, Aizawl, Naharlagan, Senapati Center, Shillong. How many of you got the aldehyde? Okay, very good. So it's a propanol. Yes, you can write it's a propanol. Okay, that is so nice. So it's easy, right? You find the addition reactions easy. The only thing is that you just have to take care, okay, that what type of reagent you are dealing with, whether it's a Markovnikov rule or the anti-Markovnikov rule. So that is all that we have done in the case of addition reactions. Let's take a 5-minute break and then we will be back with the phenol, okay? Then we will start with the phenol. We will be doing the method of preparations of the phenol. Then we will be talking about the reaction. So one topic I guess we will be covering today. So we will be done with we will be doing obviously the phenols. Okay, let's have a 5-10 minutes break and then we'll back. Okay. Okay, so I guess you people are back after the break. So we are done with all of the additions and eliminations and all these types of reactions. Let's start with the phenol. Let's write down. Okay. So we have the next heading of the phenols. First of all of you know what are the phenols, all of you are aware. I am directly going to write the preparation. First of all, we will be preparing the phenol and then we will be writing the reactions, okay? Now you people will tell me, you know them, you know the reaction. Two of the reaction we have already studied, okay? Now tell me what will be the first method of preparation. Anybody having any guesses? And I am telling you that two of the method of preparation we have already covered when we were doing the other reactions. In between we have covered it. And although today we have revised one reaction for the preparation of phenol. I'm waiting. Anybody? Very good, Satna Center. So, we can prepare the phenol by diazonium salt, right? So, I'm writing that as a very first reaction from the benzene diazonium chloride. Yes, but how can you make it from the, see, Iswa Center has written the Markovnikov rule. That was for the alcohols. Here we are talking about phenol only as well. Okay, so you cannot say that Markovnikov rule will be helpful for us in preparing the phenol. Okay, because phenol is something which is attached with the benzene, the OH group. Okay, so we can make it from benzene diazonium chloride. I am writing the reaction here. You people can also write. H2O boiling. Yes. This is also correct. Very good, Satna Center. So what we can make here? We can simply have the OH. We have done this reaction earlier. Everybody remember? When you have the diazonium and you are putting the boiling water, or the warm water is written, or water with the heat is written, you can directly make what? Phenol. Okay? This is not the Sandmeyer reaction. Sandmeyer is, when you have typically the diazonium and you are making that CuCl with HCl you are putting. That is the Sandmeyer reaction, okay? Or let's say you are having the CuCN. These three reactions are Sandmeyer. Not all of the reactions of the diazonium are Sandmeyer reaction, Iswell Center, okay? When you are making the chlorobenzene, you are making bromobenzene, or you are making the cyanide over the benzene. Those three reactions are the Sandmeyer only, okay? You cannot say this preparation is the Sandmeyer. I guess this is clear. Now we have done one more reaction, if you people remember. We have done what? Dow's process. Anybody remember what was the Dow's process? In the Dow's process, we can make the phenol from the chlorobenzene, okay? So we can have the chlorobenzene. NaOH will be written, and you know that very high temperature and a high pressure conditions were there. So either you can mention the data or you can simply write the high temperature and high pressure. So high temperature I am writing 623 Kelvin was the temperature, and you can write the high pressure. Pressure was near about 300 atm, okay? When you have this type of condition, so it will go and attack and you will be having a nucleophile here. We have written this reaction earlier. These two reactions we have already done earlier. Clear to everyone? Anyone having any doubt in these two reactions? If anybody is having any doubt, just write it down, okay? I'm waiting. Is it clear to everyone? The one is from the disonium, the another is from the Dawes process. Okay, so disonium, I guess, is clear along with the Dawes process. Very nice. Now I'm telling you one more very important reaction. It's like from the decarboxylation, or you can write by decarboxylation. Now you understand what is decarboxylation. See, like we used to say that dehalogenation. D means the removal. You are removing that particular group. Okay, if I am saying I am doing the dehalogenation, it means I am removing the halogen. If I am saying that I am doing the decarboxylation, it means I am removing the carboxylic group, right? We can prepare the alcohol using the Grignard, and then it is possible to get the phenol from the Grignard. You can, how will you prepare? There is a reaction although, Satna Center, where you can prepare the phenol from the Grignard. Yes, I will be telling you that, but in that particular reaction, you typically have, or how can you make it? First of all, you will be in that, there is one reaction, although I don't think so it is mentioned in the NCERT, but you can have the phenol, or you can have the Grignard, okay, like phenyl MgBr, and that too will be reacting with the oxygen. Then there are the chances that you can have the phenol, okay. I will be writing that, don't worry. Now we are talking about the decarboxylation. So I was just simply saying, let's say if I have this type of compound, you know the name? Anybody have any idea for the name? And if I just simply remove only the carboxylic group, what I can get? I can get the phenol. So I have to remove the carboxylic group. So very famous reagent is there, in which just by putting that reagent, that particular reagent only works for the carboxylic groups, okay? Or you can say it eats up the carboxylic group. So that reagent is known as the NaOH in the presence of CaO. The complete NaOH and CaO is known as the soda lime. So always remember, when you have the soda lime eats the carboxylic group and you will be getting the OH there, right? And what else you will be getting? It's Na2CO3. 2-hydroxybenzoic acid, the name is correct, but there is one more very beautiful common name, okay? That is known as the salicylic acid. We will be making the salicylic acid in the reactions of phenol, okay? It's a very important reaction mentioned in the NCERT also. But I am saying, I hope the soda lime is clear to everyone. Wherever you put the soda lime, it will only eat the carboxylic group, okay? And you will get the product. Write down the reaction. Okay, anybody knows the name of this compound? And you know that you people use this compound at your homes. Na2CO3. What is Na2CO3? Any idea for Na2CO3? Baking soda is well. If you eat Na2CO3, then your stomach will get a lot of problem, I am telling you. Anyone? Ma'am, do we have to remember every reagent during the reaction? Unfortunately, but yes, Naharlagan, because if you don't know the reagent, how will you write the product? So you have to write. Because the reactions which are actually following the mechanism, for them, no need to remember it. Because you know the mechanism. But for these types of reaction, you don't know the mechanism. So you have to take care of the reagent. And particularly, Naharlagan, in the chapter of phenols, for the reaction of phenols, you have to remember the reagents, okay? Sodium carbonate is the right name, Itanagar, good. But I am asking, is there any common name? Shelly, you know the answer? St. Paul, Shillong. Can we write the reactants and products only? No, Naharlagan, don't do that. Because your school, even if you are from the state board or from the NCERT or whatever board you are following, they will not give you the marks, okay? You have to write the reagent. Because what happened this time? Naharlagan Center, let's say I am giving you a conversion. I am saying you that you have to convert the salicylic acid into the phenol. It means I am already giving you the reactant and the product. Then what you have to do? For what they will give you the marks? They will give you the marks only for the reagents, okay? And they are not that tough. If you keep on revising them now, then it's easy. Okay, very nice. Now this is correct. Sercon Center said it's washing soda and Aswal said it's detergent. Actually it is. Now look at the screen. This is something which you have, I guess, studied in your P block chapter also. See, Na2CO3.10H2O. When this is written, I mean the water of crystallization is also present, then this is actually known as the washing soda. This is the washing soda which we are actually using, okay? Na2CO3.10H2O. And I am saying that I'll come to your question also, Sapna Center. Just give me a moment. If I am having only the Na2CO3, this is known as soda ash. Soda ash. No need to remember so many names. I know them, that is why I am writing it. But I am saying at least washing soda, baking soda, these are the very basic, okay? So you should know them. What is the baking soda formula? Baking soda is something, you know that, it's NaHCO3. Sodium bicarbonate is the baking soda, okay? So the baking soda which we use in the kitchen. So you can imagine, if you just, swap the baking soda and the washing soda, what will going to happen? So don't do that. You can write the names, all these three. Ma'am, for our boards, we have many questions related to the physical properties. Then, the physical properties important for JEE. I would say, Satna Center, you can just give a read. If they are asking the physical properties in your school exams, that is fine enough, okay? Not so many questions are there in the JEE related to the physical properties. They might ask you the question related to the dipole, because the JEE never asks you to write the database question, that which 4 options are given and which will be having the highest melting point. These types of questions are never there in the JEE, okay? So obviously JEE will ask you for the logics, but not for the things that you are cramming, okay? So you can just go for the these types of questions which they are asking in your school exams, okay? But apart from that, I don't think so to give a lot of focus particularly to these physical properties. So you can just cover the topics which are likely to be there in your school exams only. Now all these three, soda, washing soda, baking soda, are clear to everyone? And always remember, what is the work of soda lime? Soda lime eats the carboxylic group, okay? Now you people will tell me this is something not related to the phenol, but it is related to the soda lime, so you will answer me this also. Can you people tell me, if you have this type of case, what will be your product? NaOH and CaO. Tell me the answer. This is what? This is the benzoic acid. Everybody knows this is the benzoic acid. So when you put the soda lime in the benzoic acid, what will be the answer? Quickly tell me. No, Iswal, what I am saying, we are not making the phenol in this reaction. This is something not related to the view. It works only in eating this group. It eats this group, okay? This is the new color. So I am saying that it will eat only the carboxylic group. According to that, keep the thing in your mind and now tell me the answer as well. Still you are able to see phenol. I am able to see that this will go and it will eat this group only. I am not able to see any OH. It's benzene. Why are you writing phenyl? It's only the benzene, okay? Along with the Na2CO3, of course. Okay, so if we want to write the preparation of benzene, there also we can use it. Try one more question, everyone. Let's say now I have cyclohexane along with the carboxylic group. What will you do now? And I put the soda lime. If I have a cyclohexane attached with the carboxylic group And now I am putting the soda lime. What will be my answer? Anyone? Yes, very good, Tezwal Center. So we will be getting cyclohexane. Yes, Satna Center, you are also right. And I guess Itanagar, Shillong, you are getting the answers. So it will be what? You are getting a cyclohexane now. This is a cyclohexane, okay? No, it's not phenol. Naharlagan, it won't be same. This is what is the benzene. Are you able to see that I am only doing the decarboxylation there, nothing else. The rest, all of the same things I am putting here in the product. But I am only and only removing the carboxyl group. So this is what? This is a cyclohexane. Clear? Everyone is clear with this? The work of soda lime, I guess, is clear now. Zircon Center and Naharlagan Center. Please tell me if you are okay with this one. Quickly tell me. The rest, everyone just revise the reaction of the phenol. See how many reactions we have done till far. Here. First was the preparation from the disonium. Second was the DAOs. Third is the decarboxylation. Okay, 3 we have done. We will be doing one more, and it's again an important one. Number 4. This is from cumene hydroperoxide. Method. Anyone have the idea what is cumene? Anyone have the idea that what is cumene? Cumene is, you know that it's actually a common name. It's a common name for a compound. No, Naharlagan. We are not talking about that cumene which we use in the kitchen as a spice. No, it's not that. It's a compound, okay? Look at here. In Hindi, you know, we call it as jeera. But I'm not talking about jeera here. This is something is cumene. When you have the isopropyl benzene, either you can write the name or I can write it as cumene. Okay, so this is the name here. When you are having the isopropyl benzene, this is known as the cumene. And you know, when you react it with O2 in the presence of peroxide, now what happened? There is no any kind of anti-Markovnikov thing, absolutely not. But you people know what is the peroxy linkage? When you have this type of system, actually, you know, the H2O2 also have this. This is the arrangement of H2O2. This is the structure of H2O2. So what happened in this case? We have a peroxy linkage here, okay? I am making the... First of all, I am writing it. You people will tell me whether we should go for the mechanism or not. Because I know the mechanism. If you want, then I can tell you. So this is something with the peroxy linkage. And when you have the H3O plus, like in the presence of H plus, you know, some kind of rearrangement happens and we get the phenol here. Now I know that many of you will not digest it, how the hell it is happening, how ma'am has written all these things. First of all, write it down. I will give you a little idea that how this is happening. Obviously, it is difficult to cram the things and there is no need when everything has the logic, okay? So first of all, write it down. Then I will explain that how this is happening. I'm adding a reagent here. Like along with this, we get CH3, C double bond O and CH3. This is like the ketone we get. We get a ketone and the phenol here, okay? So whenever, this is a peroxy linkage. This is basically what you are get as a cumene. This is known as cumene hydroperoxide. Zircon center, there's nothing like, ma'am, what is the use of cumene here? It is, these are all the compounds. So if I ask you the question, what is the use of benzene? What is the use of phenol? So we are not talking about that. This is one of the method of preparation. And this particular method of preparation is generally used in the labs also. Okay, in the, I should say, the industrial process is this one of making the phenols. Okay, so they go by this method. Now written, everyone, I will be telling you that why this is happening, what happens here. Everyone has written? Because if they will be asking you the question that what is the method of preparation of phenol from the cumene, you have to write all of the steps which I have written, which you are able to see on the screen right now. Okay? So if you write all these things, you will be getting your full marks definitely. Now, I will be going to tell you that how this is happening. This is for our understanding. If you want to write in the exam, then it's very, very good. And if you don't want to write, then also it's okay. Okay. But what happened in this case? Now, first of all, I am making the, whenever cumene is reacted in the presence of peroxide with the oxygen, you get a peroxy linkage, first of all. Like this peroxy linkage I am getting. Okay. Now you people will tell me step by step. Keep your eyes on the screen. I will give you the time if you want to write. Okay. First of all, try to understand. See, if I have the H+, what do you think that where will the H+ go? Oxygen have the electrons. I have this whole system. There is a H+. What do you think? Where will the H+ go? We have done this type of thing earlier so many times. What do you people think? CO. To which oxygen? Don't you people think that it will go to the number 1 oxygen? This is the number 1 oxygen. Because, if it go to the lone pair, yes, it will go to the number 1 oxygen. There are the chances of making the water. Okay, because 1 hydrogen is already there, 1 oxygen is there, and we are adding 1 more hydrogen. Are you people getting me? I am saying this H+ will go and attack over here. It will grab the electrons of the oxygen in order to make water. Yes, Naharlagan, very good. So what will happen? So we will have CH3, CH3, then we have this type of whole system, and I am making this type of case. Okay. Now I am saying that obviously the water will go away, taking these 2 electrons, because 1 has already taken by this particular bond, na? So what will happen? So water will all say, you people just do your reaction, I don't want you, I am going away, okay? It will, have the sayonara and it will go away. So you people think so, that if the water is going away, water is taking these 2 electrons with itself and it is removing, then what charge oxygen will be having? Then there are the high chances that the oxygen will grab the positive charge. Are you people getting me? I am saying that when water will go away, we will be having the positive charge on the oxygen. Now, do you people think that oxygen will be happy to have the positive charge? Think about it. We are saying that oxygen is an electronegative atom. Okay. So, electronegative atom having the positive charge? Obviously not. Oxygen will become so upset having the positive charge over itself. Are you people getting me? So I am saying, so in order to not to have the positive charge over the oxygen, this whole phenyl goes towards the oxygen, okay? This happens. This is a kind of a migration of whole phenyl group towards the oxygen. And how will it looks like? Look at the screen. It's like CH3, CH3. Now oxygen got the phenyl. Now what do you think? Like, where will that positive charge go? It means something like, the positive charge and the phenyl are swapping their positions, okay? So, phenyl goes towards the oxygen and positive will stay at the carbon. Just tell me till far the story is clear. And no need to go in the much detail. I'm just giving you a little bit idea, obviously, okay? That this is how actually the reaction was happening. Is it clear? So oxygen was not happy having the oxygen, water goes away, then the phenyl goes towards the oxygen and we get the positive charge here. Now you people tell me, if this type of system is present and we have the water, obviously everything is happening in the solvent, that is the water. So what will or which group will attach that positive charge? Water had dissociates into H plus and OH minus. So what should I attach here at the carbon? Tell me. You people tell me. I am saying this all things is happening in the water. So which group will go? Water dissociate into, this is so common thing, we know that it's the H plus and OH minus. So which group should go towards the carbon plus? If carbon is already having the plus, we know that OH will go. Okay. So what will happen? CH3, carbon CH3, OH will be here. And then again, this type of thing will be here. Everyone is fine with the blue structure? Everyone is okay with the blue structure? Tell me if you are okay till far. Nahalagan, you are okay? Satna Center, why OH? Because water dissociates into H plus and OH minus ions. Nahin Iswal Center. How can you attach single O to the carbon? Have you ever seen a single atom oxygen going and attacking somewhere? Obviously not. We can, when the water dissociates into the ions, either I'll have the H plus or the OH minus. So hydroxide will go and attack at the positive charge. Na? Clear, Iswal Center? Take your time, no problem. Got the point? Very good. So I guess this is clear to everyone, okay? Now what happened now? As I have told you one thing, you remember that at one carbon, two OH groups are not stable. Similarly, at one carbon, one OH and one OR is also not stable. One OH and one OR is also not stable. So what will happen? Now you people will tell me, I am doing hydrolysis now, okay? When I am doing the hydrolysis, it means I am giving the H plus and OH minus. Now look at the screen, everyone. Fix your eyes on the screen. I am breaking this bond. I am breaking the carbon-oxygen bond. Now you people will tell me which charge will be on the oxygen. If I break the bond, I broke the bond, okay? Oxygen is more electronegative, it will have the negative. Carbon will have the positive. This is, everybody knows this thing. Now you people will tell me, again we have the water. What group will go towards the oxygen and what group will go towards the carbon? Tell me. You have the H plus, you have the OH minus, H plus ion and hydroxide ion. Where will they go? Tell me, where will they go? I'm waiting. H will go to the oxygen. Very good. So this was the bond. Now we have just broken that bond. Okay, we have just broken the bond. So what will happen? CH3. This is the carbon. This is again a carbon. This is the OH. And can I make it like this? Are you able to see that we got our phenol finally? We got the phenol finally. So when you give the H plus to the oxygen, see, I'm not saying, all of you are saying that, okay? That ma'am give the H plus to the oxygen. So it's very easy to remember the mechanism because, that is why the concept is important. Now you people know that from the very beginning that ma'am, when we see the H plus now, we will try to make the water, okay? We will remove the water. So in the same way, all of the process is going on, okay? I am happy that you got it. So we got the phenol. Now one more thing, very interesting. What group will be here? OH to the carbon. So OH will be here, right? Because you have given the H plus here and you have given the OH here. Now you know one more thing. See, in this particular compound, again you got the 2 OH at a single carbon. What will you do now? Tell me, we have just done this reaction in the alkyne. These all things are coming from the water itself. You have the medium water, Naharlagan, okay? Everything is going on in the, see, look at the screen. This was written, okay? Everything, why we are adding these H plus and OH minus, from where these are coming, these all are coming from the solvent water, okay? You have the solvent water. Yes, so what will you do? You will remove the water from here, and what will you form? If you remove the water from here, what will you form? You will form the ketone. Okay, so we get the ketone. So this is what? Acetone, and this is my phenol. See, we started, we have written this thing. Just look at the screen. We have written this thing earlier, and we got our products, okay? So this was all of the mechanism part. If you want to write, you can write. What about the O2 and H2O? O2 and H2O works here only. Look at the screen, Naharlagan. This is what I have written after reacting the cumene with the H2O2. Because of the H2O2, I got the peroxy linkage here, okay? After that, this whole thing was, I was explaining you this particular thing, okay? That how I got the product. This is the work of H2O2. You got the peroxy linkage here. This is the only work. When you have the oxygen, when you have the peroxide, they together will give you the peroxy linkage, okay? So I guess, Naharlagan, it's clear to you now. It takes a lot of time to just write one single mechanism. But I'm happy that the concept is clear for many of you, okay? That you will not say that how it is happening. We were started from the cumene and we got the phenol, okay? And this is an important reaction. This is mentioned in the NCERT also. So do not miss it. So this is a very important chemical reaction. Naharlagan, I hope you got it. Everybody, any doubt now in the cumene? And we have done a complete foolproof mechanism also. Yes, this is a long reaction, okay? Yes, peroxy linkage means when you get two OO. When one oxygen is attached with the another oxygen, this is known as the peroxy linkage, okay? And this is the long reaction, so I hope now everybody will remember what is the cumene, okay? You will always remember what is cumene. I hope you are done with this one. So these were only the method of preparations, okay? So look at the screen again. Let's revise. The first was from the benzene diazonium chloride. The next is the Dow's process again. The next is decarboxylation. You get to know about the soda lime today. And the next was the cumene hydroperoxide method, okay? So 4 method of preparations we have done. We will do some of the little questions now, 2 or 3 only, and the reactions. I'm not starting the chemical reactions of the phenol because you know that will get a lot of things now. So we will be doing the chemical reactions in the next class. I guess tomorrow we'll have the next class, na? And today I'll share one more PDF with you. Try to practice the questions, okay? Try to practice the question. I will share one more PDF, but we still have the 5 minutes. So look at the screen. We'll revise the common names. You people say na that ma'am it's very difficult to learn the common names. Wait, St. Paul, we are not going anywhere. Just wait. They are saying bye-bye. We are revising the common names. Everyone, just you have to type with the keyboard, okay? What is this? We all know this is benzene. You know that. What is this? Tell me what is this? St. Paul was in so hurry. St. Paul only 5 common names, okay? Then you are free to go. Quickly write down what is this. Yes, this is what? This is toluene. This is the toluene. Then we have one more here. What about OCH3? And now you people remember this one. What about the OCH3? Methyl benzene is also the correct name, but the common name is toluene, okay? When we are saying OCH3, you can either write the methoxybenzene or the name is N-izole. Everyone, this is N-izole, okay? And what about the third one? This is now cumene. This is the cumene. We have done this reaction, this particular compound today. What is the name of the fourth one? Now Lagan is happy, yes. And you know the name of the third one also, the fourth one, sorry. Fourth one, what is the name? Quickly, I am waiting. Salicylene. Very good as well. Spellings are wrong. Salicylic acid, okay? It's the salicylic acid. Always remember, whenever you have a phenol that is attached with the carboxylic group, this is known as salicylic acid. Salicylic acid, okay? Let's do only the one more, the last one. And you can have the guess also over here. What if now I have the phenol but with CHO? This time I don't have the acid, I have the aldehyde. So what will be the name? Think about it. You have the phenol and you have the CHO. So what will be the name? Something obviously related to the salicyl. But this will be salicyl aldehyde. Okay. So this is salicyl aldehyde. Clear to everyone? So these are the very basic 5 common names. We'll try to learn more common names in the tomorrow's class. And one very important thing is pyridine and pyrrole. Satna Center, look at here. This is pyridine. This is pyridine. And this is pyrrole. And if you have any other doubt, now Satna Center, I am there in your group, okay? So you can ask me your doubts over there. I will solve your doubts there. I will try to send one assignment today. So just try to solve it. And very, very important thing is, because tomorrow we have the next chemistry class, so it's very important to revise the whole notebook today itself, okay? So just revise the reaction, because tomorrow we will study some more reaction, so it will, pile up. So I don't want that. So keep on revising the things, and then definitely you will enjoy the organic chemistry, right? So I guess it's clear now to everyone. Okay, then if you have any kind of doubt, anyone regarding the today's lecture or in the previous class, then you can just post them in the WhatsApp group. I will be solving your queries over there. Thank you so much for the today's class. See you in the next class. Thank you. Bye-bye.